Hello and good afternoon. So my name is Yoav Reches. I'm originally from Israel, and I live in London for the last 6 years. And I'm going to show you a quick overview of what I'm doing, where do I come from, and potentially where it's heading. So we're going to cover a bit of my work and I would say the brief history of Formlabs, or at least from my perspective. So I start my making, or being involved in making, at a very early stage, joining a group of artists called Zik. These guys started very early, 1985, and that's before the Burning Man movement even started, building gigantic installations and burning them as a performance. For me, it was, I would say, the best school for material processes, and also the deep understanding that maybe my focus or my interest lies in the process, because all the work that was done throughout even more than a year is set on fire in one installation. And in a cruel but still beautiful way, it clears up the studio and really allows you to start fresh. So layer by layer, I would say my romance with layers started very early on. My father is an architect, and as a student, I find the easiest way to make a living and to pay my bills was to work for his firm as a model maker. So that was one of those gigantic tasks, more than 800 layers of cork cut by hand, glued together, landscape between Jerusalem and the Dead Sea. But then I guess then I realized that you can get to any shape laying down the layers in a slightly different contour, one on top of the other. So you can stack those blueprints one on top of the other and get not only to a very complex geometry, but also embed mechanisms or allow things to happen between those layers. I went to study product design at the Bezalel Academy of Art and Design. This is a glimpse into my graduation projects, which looked at, on one hand, traditional manufacturing or craft, and more industrial way of processing materials. So we slip cast ceramics and then polyurethane foam processed on a lathe and by CNC machines. So the process of slip casting is centuries old, and it involves starting with a model. These models were made out of MDF, stacked, glued and put on a lathe to get the final shape. And then the plaster molds and the clay. And then you can see the CNC carving these blocks, getting to those more complex shapes. But then again, still, subtractive or additive, these all had something very interesting in how they worked in layers. Another project that kind of, at some point, or maybe, let's say 10 or 12 years later, brought these two qualities together, the ceramic work and the model making, was done in collaboration with a good friend and a designer called Noam Dover, in which we took a landscape, we built the actual model of it from MDF, and we put it on a lathe, and we gave it an outer shell, we made a mold, we casted it in clay, and we got this vessel that, in a very beautiful, metaphorical way, represents a landscape by using a material which is earth. So my first big project, I would say, touching 3D printing was in 2007. I was invited to take part in an exhibition at the Israeli Museum, in which I was given a build volume of an object printer. And it was roughly a shoebox size volume. And I was trying to come up with either the smallest thing I can work around because it has these qualities, or there are these possibilities of doing something extremely small, which is unique to additive technology. or the biggest thing. And I kind of realized very early on that it would be interesting to look at kind of a natural models of growth. This one particularly is inspired by horns of animals, and how that is growing in a way layer by layer, like trees are growing or adding a layer each year inside out. So I decided to see if I can actually create a very big object using the limitations of that build volume. So the piece that you see is 9.5 meters long. It's printed in one print. It took 100 hours. For fitting it into the build volume, I had to build some kind of a logic, a way that one container could be nested in the other. But the more interesting results I was experiencing playing with the CAD model is that this thing started teaching me what it could be or want to be. And at the very end, after a long wait, when I got the print, it was very difficult to decide in which configuration to actually exhibit that, because the model had a locking feature that allows all these configurations to take place. Another moment that 3D printing became, I would say, important or a game changer for me was that I was invited to take part in an exhibition that was looking into jewelry. And I would say I'm trained as an artist or a product designer. I have only intuition when it comes to precious metals. But being able to actually model things in CAD and explore geometry and find a connection to history kind of allowed me to leap into this world and become a craftsman for a moment, because the inspiration came from wire jewelry, which is like one of the most ancient forms of jewelry, in which a wire was pulled, manipulated, and then soldered together. So this print was printed in wax, then casted in silver, then the molds were made, and then copies of wax copies were made, and then cast again in gold and silver. Then I went to the Royal College of Art. What I find interesting about the college, at least in those years, 2008, 2010, is that the course, the design product course, was still more focused on training you not to be maybe a better designer, but to actually ask questions about manufacturing, about users, about the whole role of design, but also to kind of allow you to build a connection, or at least that's the process I went through, to reconnect to materials and processes and to actually question fundamental questions about manufacturing. So one of the amazing opportunities that the college allowed me is to work with Sèvres. Sèvres is a French porcelain manufacturer, 270 years of tradition. They've been doing porcelain for Napoleon. And I was invited to take part in an exhibition in which one of the main focuses of my work was to try to celebrate their work using magnifying lenses. And I've made a series of these lens holders that kind of coexist with the pieces. That was, for me, a great moment to utilize laser cutting and to kind of enjoy the freedom that, I guess, the last 10 years offers, I would say, small businesses or designers or makers to actually approach industries and to actually make stuff which is very limited in its like production numbers. So yeah, there was a series of these moments where you can see the accuracy and the quality of the detail of their work. But throughout the process of working with them, with the lens project, I've developed a teapot which kind of celebrates one of their glory moments in history about making, this is the top right diagram, they're making a double wall teapot and then they're adding a decoration on the outer layer. So I've decided to make or to propose some kind of take on that approach. Again, with the very clear view that we can 3D print ceramics, and we can get to geometries which were earlier on would cost us hundreds of man-hours. With a single print or with 2 prints, you can actually create geometries which are almost redefining or challenging the concept of a teapot, insulating it to heat, also the transition between the handle and the spout, which is basically it's all one single body, one single surface. It also correlates with the Klein bottle and other mathematical models. The results were printed on a Z-Corp machine and then manually kind of engraved. That was more of an exploration session. And if there's somebody who's printing ceramics in the audience, I would really love to produce that piece. One last project, which was part of my graduation from the RCA, was trying to kind of redefine knockdown furniture. I was trying to create something which is simpler than IKEA furniture. So I was trying to find a method that would not need a manual to assemble a piece of furniture. So what you see is a series of parts which are CNC machined and then put together only by tension of a rope going through that groove. Again, to be able to work with those CNC routers or 2-dimensional machining tools and to actually be your own manufacturer in a way. Not that I own the tool, but I mean the ease of actually approaching people who actually own the tools was great, and I've produced a series of these pieces, different configurations, different materials. But in a way, what happened throughout all these processes is that I understood that really empowering a maker these days is having the access to the tools. And after the Royal College of Art, I was fortunate enough to get a scholarship to go and do a residency at MIT Media Lab, working on a particular project called Luminar, done then by Nathan Linder, who's also a founder of Formlabs. So that was, for me, doing a lot of, I would say, low-tech and crafty work. That was, for me, a big leap into the world of consumer electronics and technology in general and robotics in particular. This project was trying to redefine the bulb, the light bulb, and by embedding a projector, a set of cameras, also a speaker into it, it would allow a user to actually control a projection using hand gestures and what is called augmented reality. So you can teach the machine what kind of gestures you would like to see your browser, to see your mail, but also because it's a camera system, you can actually open a magazine, take a snapshot, then project it, do a sketch on it with Photoshop. So one of the most interesting aspect of this project was that it was trying to reconsider or rethink the objects that we know. This is based on an angle poise design of a desk lamp and trying to embed intelligence or some kind of a mechanical system to allow the object that you interact with to look exactly like the desk lamp that you have on your table. In a way, in a weird way, the process of working both on skeleton and on shells bounced me back years back when I did some consulting work for bigger companies, but I found that it's really interesting to be part of a project very early on and to be able to allow the design and the user-centered approach to influence interaction with objects. So you can see an exploration, series of prototypes. They all contain a step in the evolution of the actual product. But what's, I guess, more valuable when it comes to the Media Lab is that the Media Lab is an amazing working environment. And in this working environment, almost accidentally, I would say over a beer, I met these two guys. Well, Nathan is the guy I worked with, but Max and David, which later became, all three of them, the founders of Formlabs. So I knew Nathan from childhood, but Max and David were these two vibrant engineers that constantly wanted to make tools. They were all about making tools, and if you look at a lot of the work that is origined from the Media Lab, you see that there's a big focus on making the tools of tomorrow or questioning the existing tools and maybe offering an alternative. And they showed me this. They showed me a series of prototypes, all made in a very engineering manner. 80-20 profiles, very crude motors, all the electronics are exposed. But believe it or not, these models produced this middle rook, this middle print. And when I saw this, I was really amazed, because having worked with several machines in the additive manufacturing field, I always knew that stereolithography is like, wow, that costs a fortune, and only if you have a really rich client you can say, okay, let's 3D print that and be really happy and maybe abuse the volume a little bit and print something of your own inside, nested inside the print that you're doing for him. But what really amazed me, that, I mean, and you've probably seen comparisons between different machines and different technologies. This is an FDM machine, the filament, which is extruded from a hot nozzle. This is a Formlab machine, and this is one of the high-end machines, the stereolithography machines. And when I heard like what would be the retail price, I was really shocked. And at that point, I think I kind of fell in love with this idea of making a tool, because I was, for several years, I've been moving away from actually making consumer products, and I found myself that, wow, this is a tool that will help other people to create. So there's something more of a distance. You don't have to create to play on desire. You have to actually play on the properties of the actual tool. So yeah, saying tools, I had to define that as a crucial part of my brief. But the difficult thing came when I had to actually research into the history of 3D printing. And yes, this was 2011. But the only thing that I could find at the professional was a fridge-sized machines. And I said, okay, let's invent that history, or let's try and grab inspiration from somewhere else. And another crucial thing that was part of that brief was that there is an element of freedom that we can actually move from a factory environment into a studio environment. And that kind of defined our users. Now, there's a big discussion, and everyone's saying prosumer, user, pro-user, professional, hobby. Basically, we understood that we're making a very powerful tool. So our user has to come from an environment which he knows the difference. Also, he's willing to invest the money into a slightly more expensive machine. So, as I said, inspiration had to come from other places. This is one of those mood boards. As you can see, there's no 3D printers here. There's I would say details from the stereo or radio, typewriting, furniture. The notion of transparency was very present while we were working on this in that initial stage of grabbing I would say the inspiration and solidifying our concepts. And then there was a deep dive into what this machine could look like, and there were a lot of possibilities, and we knew that volume plays a crucial role once you create a tool that in its volume allows you to create whatever you want. So that was a kind of a key understanding, that at some point we have to create something almost transparent. So besides the mechanical system in which the engineers were very focused on and trying to get to either source the best components or either build the best rig to mount them on, my focus in terms of the early stages was on those pieces which the user interacts with. And it was because we were in a way, the first to bring stereolithography to that environment, we had to actually reconsider or redesign a lot of what we thought is obvious for us, but it had to be, in a way, monkey-proof for the real world to actually make that printer work. So the user had to deal with some kind of a tank that contains resin. The user has to touch some kind of a platform which attaches and disattaches from the machine, and the print is actually done on it. And of course, the cover, the shells, all the sheet metal parts, or the cover components. One very crucial understanding that happened early on is that the more we can separate the mechanical system from the making chamber, the more we allow that transparency to happen, in a way. When I'm saying transparency, I'm looking at this notion that the design is so integral and you actually focused on what you're making and you're not obscured or bothered by how the machine shows it to you. So that clear division of a body and a cover was really kind of new and fresh for us and allowed a lot of angles in which, if put in a corner of the studio, you could still see from the other corner of the room whether your print is done, print is ready, the machine is working, etc., etc. So of course, ergonomics and user studies, because SLA was never done on a desktop then, I mean, well, it was done, but it wasn't really designed for the studio environment. It was still designed for, I would say, small workshops, dental or jewelry workshops, in which you had to engage with a very complicated software and basically become a mini technician of that machine. So it wasn't open to the public to actually engage with stereolithography. So yes, stereolithography, we've done a process, we've worked with a process which is called reverse stereolithography, in which we actually shoot the laser from the bottom into a transparent window at the bottom of the tank, allowing the platform to actually be isolating the layer thickness, and slowly the object is pulled out of the tank. As you all probably know or not, we have launched our product in Kickstarter and got amazing response from the community. And that was also a really great moment to understand that the people were waiting for such a product, because it is so fundamentally different from the other consumer, or I would say low-end machines that people going into 3D printing would like to purchase, like FDM machines. It actually allowed people to reconsider their work and see if they actually need something better to improve their business. The company since then is growing, and I have to say they're growing very fast. That's Formlabs as for a month ago. And recently we've launched a version of the Form1, which we call the Form1 Plus, which was basically the time it took us to really optimize and grow enough to actually outsource the right components and not compromise for what the market early on offered us. So new lasers, new motors, a lot of development into the electronics of the machine. So the Form1 Plus is basically the same form factor, but much better results and much faster results. So this is an illustration of how the laser, you have a laser source, two components which are called galvanometers that moves and manipulate a mirror, and then two other mirrors that allows the beam to be exposing the resin at the bottom of the tank. So this is a time lapse of that process. So the current configuration of the machine is offering three different resolutions, which is 25 microns, 50, and 100. The feature size is 300, and the print envelope is 125 by 125 by 165. And this is a demonstration of what these resolutions, or how these layers are looking like. with the naked eye, it would be really hard to spot the difference between those resolutions, and we take it as a compliment because anyhow, I think knowing that this is a 3,300 US dollars machine, the results are pretty impressive to begin with. And then observing and basically continuing to work on other developments in the company, we started getting feedback and started getting those photos which we always dreamed that this would be the scenario that our machine would live in, and those would be the makers, and it will blend into the working environment, and it's quiet enough to sit on your desktop and not to bother you, and it looks like a very sharp piece of machinery. Another thing that in a way took quite some time to get that feedback is being included in that level of machines. When you type in professional 3D printing, you do get one of our machines on, so it was a great moment of pride to be on a Google search with all these big names. So coming to think about how to work with it or how one interacts with the machine. So yeah, for actually printing, you actually need to plug it into the electricity, add some resin, and then you get the parts. But that has to go through a piece of software, and under the assumption that the users who buy this machine are at some level of know and work with CAD software, we really try to make the simplest tool to allow the conversion between those very different softwares into the printer. So we created Preform as part of our, I would say, working environment. Or yeah, and Preform actually offer you to actually prepare your models to print, and those specific details that you have to add, such as support materials, or define the type of material, or the layer thickness. It's all done there, but we're not trying to create a CAD tool. We're just trying to actually give you the simplest, almost adapter from your working environment into the real world. Another thing that is included in the kit is some sort of a finishing tool. The resin needs to be washed off the part. Since it's coming out of the actual resin tray, it's all covered with resin when it comes out. So you drop it in a bath of alcohol, allowing it to soak for 10 minutes, and then you scrape it off the platform. And then you can see in one of the parts that is moving around, you can see these support structures that later on you have to actually break and sand those touch points. So when it comes to materials, what we have now is 4 materials. And when I'm talking, and yeah, a lot of you probably know, and this conference actually shows a lot of these qualities, in my mind, I would kind of define 3 different categories for materials. One is modeling materials, in which a lot of these plastics are kind of used for, regardless of the technology making or manipulating them. And then there are transitional materials, such as wax or more rubbery materials, which are used for mold. And then you have the functional materials, and we can see a lot of them. Either it's like printing in a good quality ABS, or either printing directly in metal or ceramics, etc., etc. So Formlabs is relatively at the stage where it's allowing modeling materials, these 4 colors, but they are functional. So if you need to make a model and then make a mold on top of it, I would regard that as a function. So the material is stable, it's very accurate, and it allows you to move on if you are considering other types of production. In the pipeline, we have transitional materials such as rubbery materials and burnout materials, which is used for casting. Another quite a nice advantage of stereolithography, is that you can create watertight materials or structures, sorry. So this is a tube going through a solid piece of material, and this is one application that you can make liquid mixtures. So you can see a blue and a yellow resin or liquid is introduced into a mixing kind of chamber or channel, and allows these two liquids to mix in an equal way. So watertight or liquid tight. And then also, if you look at the market of 3D printing, if you're looking for transparency, it's kind of hard to get models which are transparent or materials which are clearly clear and see-through. The FDM environment do offer a few transparent materials, but you cannot get to that type of polish. It's only SLA or stereolithography. Another very nice feature of developing a 3D printer while using a 3D printer is that you can actually mimic and check and print the objects you're about to commit in large, like ordering them in large numbers, such as injection molding. So we were fortunate to play a lot and model a lot of our existing components of our machine, and to actually feel them and hold them, and yeah, the qualities are almost the same. As for the freedom, I mean, structures or models which are structural, our machine really likes them because there's less need of support structures, but you can get to very complicated geometries and get beautiful results out of them. So as for our users, and this is something we are kind of happy to celebrate these days with a lot of our new users or semi-new users, is that option that you guys are either want to collaborate with us or have an interesting ideas, you are more than welcome to contact us. And this is a project that was done with Marcelo Coelho and Skylar Tebis in collaboration with us.
Software tools are empowering individuals to envision, create and share their own designs. At low cost, 3D printers allow objects to be built and consumed from the comfort of our homes. However, as 3D printers become smaller, so does their print volume, limiting the scale of objects we can construct. Imagine all of the things we can't print today. The team behind Hyperform combined their backgrounds in reconfigurable systems, smart materials, and 4D printing to tackle the problem of small print volumes. Hyperform addresses this problem by using folding as a computational design strategy. Folding is a universal strategy for reconfiguring shapes and can be found in both natural and synthetic systems. This allows geometry to be compressed into a minimal volume. Hyperform consists of 5 steps. Starting from a large-scale object, density is relocated from volume to line and broken up into a single part. A custom-designed universal joint is distributed along the path. Programmable notches encode angle information. The generated chain is folded into a 3-dimensional Hilbert curve to maximize the volume in the print bed. The chain is then printed. Finally, the printed chain is then unraveled and assembled into the programmed object. The initial design can take any 1D, 2D or 3D configuration. This process allows for a 50-foot long chain to fit into a small volume, creating the world's longest 3D print. A chandelier 8 times larger than the print volume was also created using this technique. This project points towards wider applications of 3D printing in the near future by utilising folding and self-folding material systems.
This is one example of collaborations, and there's a few more, so stay tuned for our publications. But let's go through very quickly. Let's go through several case studies, and these are all images that are coming from our users. They're sending it back, and we're very happy to kind of celebrate and put them on our web platform and to kind of celebrate their making. So from the electronic, a more engineering point of view, I think the medical environment are starting to recognize the power and the accuracy of our tool, and I would say artists in general, CAD artists that are spending a lot of hours in front of their models. They're also very satisfied to get the result or the resolution that they were sculpting in mind with, and get those prints out. A very interesting niche that we found that really embraces our machine is, I would say, the CGI or 3D animation modeling. This is Robert Vignon, a few of his figurines. He takes another or few extra steps to finish his pieces. Brian Anderson, a toy maker or an artist, and Adam McMayton, which also creates models for more the animation or the movie industry. And I think that's it.